Stephen, did you bring your pen?
I'm just going to take it extension.
Okay. I will put that in later on. Okay. All right. Now, yesterday we were in the middle of this problem, and we really need to get this figured out. So remember what we were doing? We were going to write the equation given the picture. Remember that? We were in the middle of that? So we're on review sheet 4, and that means chapter 4, not number 4. And we had this picture. And we were going to write the equation. Okay. So we were talking about the fact that in a sine equation, or cosine equation, or tangent equation, in any equation, there are really 4 places where numbers can be stuck in. And what do all of those positions do in terms of the equation? Well, this one impacts or has to do with what? Amplitude. So I look at my picture. What's the amplitude of my picture? 4. So I'm going to put a 4 there. Now, once in a while, that could be negative. When would that 4 need to be negative? If the picture had been upside down, right? Then the 4 would be negative. But it's the right side up, so it's a positive 4. Okay, what does this number have to do with? The period. Now, what is the period supposed to be? 2 pi. Well, this period is not 2 pi. This period is 4/3 pi. 4 pi over 3. 4/3 pi. So obviously, we have changed the period. It is no longer 2 pi. It was supposed to be, but it isn't anymore. So how do we find the period? If I give you the equation, how do you find the period? 2 pi divided by that number, right? That's how we find the period. So 2 pi divided by that number must equal 4 pi over 3 in this problem, because the period is 4 pi over 3. So whatever number I put in there, when I divide 2 pi by it, I get 4 pi over 3. So what does that number have to be? Now we'll just cross multiply and divide. What's 6 pi over 4 pi? 3 halves. All right, what does this number do? Sideways movement, right? Take a look at the picture. Has it been moved sideways? No, it's starting right where it's supposed to start, right? So I'm just going to put a 0 in there. You can leave that out completely if you want. But since I have a blank there, I'm going to put a 0 in. How about that last blank? What does that have to do with? Vertical shift. Has this picture been moved up and down? No, you can tell. It goes up to 4 and down to -4. That's perfectly balanced. So that's also a 0. So if you wanted to simplify that, I mean, I wouldn't count that wrong, but if you wanted to simplify it, make it look a little nicer, that would be the equation, right? Now, we talked about this a little bit yesterday. Because this curve goes on in both directions, it could be a cosine curve. If it were a cosine curve, we would be looking maybe at this section of it. Now, there are other sections we could look at, but would that red section be a cosine?
Yeah.
So what would that equation look like if it were a cosine curve? Well, you're going to have all the same blanks. And the good news is, if I look at that as a cosine, has the amplitude changed? No, so that's still a 4. Has the period changed? No, so that's still a 3/2. Has the vertical shift changed? No, so that's still a 0. Those numbers are all going to match. The shape of the curve hasn't changed. The only thing that's changed is, instead of starting at 0, where does the red curve start? Pi over 3. So this would have to be x minus pi over 3. Now there are actually infinitely many answers to this question, because someone else might say, I don't want to look at the red one, I want to look at the blue one. Now could the blue one be a cosine curve? Yeah. What about it though? It's upside down, so this would have to be a negative. Everything else is the same except your phase shift. What would your phase shift be? I don't have it labeled, but what would it be? Negative pi over 3. So if you did the blue one, you'd have to put a negative here. And how would this change?
Positive.
X plus pi over 3. Somebody else might say, I don't want to look at any of those sections. I want to look at this section right here. What would that section be? You're allowed to look at any section you want. What would this section be? What shape is that? A negative sign. So you could write an equation for that section. This problem is a grading nightmare because there are infinitely many answers. But what will they all have in common? They'll all have a 4 or a negative 4. They'll all have a 3/2. And they'll all have a 0. The only thing that changes is where you start looking. If you start looking at 0, it's a sine curve. If you start looking at pi over 3, it's a cosine curve. If you start looking at 2 pi over 3, it's a negative sine curve, and so on and so on and so on. You will be responsible for writing one equation of each, one sine and one cosine. Okay, let's look at the next one. There's another one on there. Okay, so let's see. So there's the picture. Now we are going to write a sine equation and a cosine equation. Okay?
A question for the cosine of that, would the cosine range from the negative pi 8 to 3 pi 8?
It could.
Or would it go?
Remember, there are infinitely many pieces, infinitely many ways. If you want to look at that piece of it, that's absolutely fine. That would be a picture, that would be a cosine. That would be a period of the cosine. And if, since we've got that one up there now, that's a cosine, what about that cosine? If that's the one you choose, what about it? It's negative, right? So this number is going to have to be negative if that's the period you're looking at. What's its amplitude? 2. What's its period? No, that's not 4 pi. Yes, it's 4 pi divided by 8, which is pi over 2. So the period is pi over 2. What's the period supposed to be? 2 pi. So 2 pi has been divided by something to get pi over 2. So what does that have to be? 4. Now, if you choose to use the red section like she did, then what's going to go in this parentheses right here? X plus pi divided by 8, because you shifted back. And does this one have a vertical shift? Yes, it is not oscillating across the x-axis. How far has that been picked up? 4 units. That's been picked up 4 units. Its new axis, you know, that it's squiggling around, is up at 4. Now, for the sine equation, remember what I said earlier? Will the amplitude change? Nope. Will the period change? Nope. Will the vertical shift change? Nope. Same picture. It's exactly the same picture. We're just going to look at a different piece of it. So what piece do we want to look at if it's a sine curve? There are tons of them, but I just like to look at this piece. Why is that piece so nice? It's positive and it hasn't been moved, right? It's starting right where it's supposed to. So I'm just going to put a 0 in there and I'm done. Now, are there other sine curves you could look at? Absolutely. Absolutely. For example, if you started here, you'd have a negative sine curve, right? You could start there. You could start over here. Have another negative sine curve. Okay, we'll talk more about that. What we need to do now is get our quizzes back and go over these guys, because we're going to have another quiz. These were 23 points, and we have got to get all of this under control. Stride. Very.
What is it out of? 23.
Stephen did really well. Stephen always does really well. Stephen, what'd you get? Like a 28? No. Yeah, I know.
Isn't it out of 22?
It's out of 22. Stephen got one. Remember,
Okay.
my birthday.
I don't think I got that.
Now,
I don't think they got this problem right. The vertical shift was negative.
you guys got the harder problem this time.
Oh, my.
I know. You know, you have to mix it up and spread it out over all the periods. So you guys got a little bit tougher one. Here's why it was a little bit tougher. You are supposed to be able to handle this, people. Some of you, I don't know what you're doing. You're making it way harder than it is. But this did have a little bit of a trick in the middle of it if you weren't paying attention when we talked about this in class. You can't graph this equation just yet. what do you have to do first before you start graphing it? What?
You have to pull the 2
You
out.
gotta pull the 2 out. You have to pull the 2 out. So, we'll do that. And what will this be if I pull that 2 out? What would I have to put here so that when I multiplied it back, I'd get pi?
1/2.
Pi divided by 2. That's exactly right. That is exactly right. Now this equation's ready to graph. Now think about what we just did. Think about when we wrote the equation. What does this number do? Amplitude. So I'm going to graph a sine curve that has an amplitude of 3. Oh, maybe I won't start there. It's going to go up to 3 and down to -3. Okay? What does that number do? That divides the period. So my period is supposed to be 2 pi, but it's been divided by 2, so now my period is pi. That means beginning to end is pi. Okay, what does this do? That means I'm going to start pi over 2 to the left. What does that mean?
Vertical shift.
It means when I'm all done and I got my picture all drawn, I'm going to lower everything 1 unit. I'm going to wait on that. Let's get this thing drawn first. This is a sine curve, a positive sine curve, and it has a period of pi. Now think about this for a second, you guys. If it starts at -1/2 and its period is 1, where is it going to stop?
1/2.
At +1/2. This is -1/2 plus pi. That's how that number came into being. So you've got a sine curve that goes up on this half and down on this half. Can you figure out what these labels would be? The midpoint, of course, is the origin. What are these labels going to be?
4.
Fourths. So that's a +4th and a -4th. Now that is perfect except for this, right? We haven't done that yet. So we'll just take every point and drop it down 1. So your actual answer is the blue thing. What is the amplitude? We're filling in those blanks over there. What is the amplitude?
Still 3.
3. What is the period?
5.
What's the frequency? 1/pi. What's the phase shift? -pi/2, or some of you say left pi/2. That's fine. What is your vertical shift?
-1.
-1 or down 1. What's the period of the equation in number 2? Pi divided by 3. You guys, it's a tangent. Everything has a period of 2 pi, a standard period of 2 pi, except tan and cotangent. So pi/3. The next one, find the radius. What pops into your head when you see a picture that looks like that? I'll tell you what pops into my head. Arc length equals radius times radians. What's the arc length?
6.
What's the radius?
R.
What's the radian measure of the angle?
Pi/5.
Pi/5. To solve this equation, Stephen, I know you did well on your quiz, and that's awesome, but you need to let everybody else pay attention. To solve this equation, we need to do what? You guys, you're seniors in high school. This is outrageous. We need to solve for r, which means we need to.
You gotta take that 5.
You gotta get rid of that pi over 5, right?
Yeah.
Now, some of you can't do that, so do it in 2 different steps. Times both sides by 5. So now you have 30 equals r times pi, right? Because those cancel. So then what?
Divide by pi.
Divide by pi, so r equals 30 divided by pi. That's your radius. It is that simple. Convert 16 degrees to radians. Some of us miss this. Pi over 180 equals something over 16. We're looking for the something. So the something will be 16 pi over 180. Both of those numbers are divisible by 4, so it's 4 pi over 45. And yes, I do expect you to be able to do that arithmetic without a calculator. You are capable. I have complete confidence. Okay, other side. What does the pi over 2 to pi part, what is that telling me? It's in quadrant 2. So my butterfly bow tie in quadrant 2. Cosine 2/3, or negative 2/3. Cosine negative 2/3. Does that look right? Now I need to find that guy right there. How am I going to find that right there?
Pythagoras.
I'm going to go to Pythagoras, absolutely. Now, am I going to add 9 and 4? No, I'm going to subtract 9 and 4. So this is going to be root 5. Positive or negative?
Positive.
Positive. Now I want the tangent. What's the tangent? Negative root 5 over 2. It's opposite over adjacent, y over x, however you want to think about it. That's the answer. Anybody have a question about that? Find the exact value of the sine of 7 pi over 6. Okay, what did you do with 7 pi over 6? Changed it into 210, hopefully, right? Then you drew a picture of it. Said, all right, 210 is down here. There's my butterfly bow tie. What's the reference angle? This is the only angle you care about right here. How big is it?
60.
Okay, now see, somebody said 60.
It's 30.
It's 30. You have got to be able to see, gang, that this is 180. If I'm going to 210, I'm going 30 more. That's 30. So this is 1, this is root 3, and this is 2. And these two are both negative, right? Left and down. So what's my sign?
-1.
Negative 1/2. Secant, negative 90. Where is negative 90?
Opposite.
Right here, isn't it? What do I do when I'm on an axis? I can't draw my butterfly bow tie. So what do I do when I'm on an axis? Pick a radius. So I'm going to use 1. So my radius is 1. What are the coordinates of this point then? What's x and y if I'm sitting down here?
0, 1.
0, negative
Negative
1. I want the secant. Secant is reciprocal of cosine. Cosine is x over r, so secant will be r over x, which is 1 over 0, which is undefined. You cannot sit on the egg. It is undefined. cotangent, 5 pi over 4, what did you do with that?
Pi is 180.
Change it into 225?
Yeah.
225 is down here in quadrant 3 again. What's the reference angle for 225? 45. So we have a 1, 1, root 2, and again, both of those are negative. And we want the cotangent. Cotangent is adjacent over opposite, which would be -1 over -1, which is what? Did I make a mistake on your paper, Katie?
The answer's long, right?
Mm-hmm.
I have one there.
Okay, show it to me after class, I'll fix it. Okay, an eagle on the top of a tree spots a sleeping mouse on the ground 123 feet from the base of the tree. All right, we need to make sure we can draw the picture. You cannot get the right equation if you put the numbers in the wrong spot in your picture. Here is the eagle in the top of the tree. Here is the mouse sleeping on the ground. The eagle is looking at the mouse. Where do I put the 123?
The bottom.
It says that words are right there. 123 feet from the base of the tree. This is your 123. What is this? What distance would this be?
That's
Well,
the top of the
we
tree.
don't know, but that's the distance from the eagle to the mouse. This 123 is the distance from the mouse to the base of the tree. 123 goes right here. If the eagle's angle of depression is 13 degrees, find his distance from the mouse. That's what I'm looking for. The eagle's distance from the mouse. Where do I put the 13? 13 degrees. Where do I put that?
About that.
Technically, it's here. That's the angle of depression. But I know that the angle of depression is the same as the angle of elevation, so it's easier for me to put the 13 inside the triangle. Now, some of you put the 13 here, which is absolutely right, and then you found this angle, and you use that angle. That's perfectly okay too, as long as you use the right function. I'm going to put my 13 there, so what function am I going to use? Cosine 13 is 123 over x, so x equals 123 over cosine 13. Now, if you used a different function, and a bunch of you did, I know we've done a lot of tangent problems, and a bunch of you used tangent on this. I don't know why. Okay, we good? Okay. Tomorrow we're going to have another quiz.
Oh, goodness.
Oh, yes. Now, what is going to be on this other quiz in addition to this?
Things.
We did not have enough perfect papers. We had hardly any perfect papers on this, and we need to get perfect papers on this.
Oh,
So
good.
our quiz is going to be over this again, all this stuff.
Oh,
What else will be on the quiz?
nothing.
Well, here's what else will be on the quiz.
Now,
What is the period of this function? Remember, we did this one day, we didn't spend much time on it, let's see if we can remember. If we want to know the period of the whole thing, how do we start?
2 pi.
You multiply together, or add,
No, well, I don't know, maybe, I don't quite understand what you're saying. If we want the period of the whole thing, we're going to start by finding the period of each individual piece. Okay? So how do we find the period of each individual piece? All right, well, what's the period of this piece?
Pi.
Yeah, it's 2 pi divided by 2, so this period's pi. What's the period of this piece? 2 pi divided by 3, or 2 pi divided by 3. Now, this means that every pi unit, this thing repeats itself. So new periods begin at pi, 2 pi, 3 pi, 4 pi, and so on. That's what this means, right? Now, when do new periods of that begin? Well, you got a new period of 2 pi over 3, 4 pi over 3, 6 pi over 3,
2 pi.
which is 2 pi. So both pieces of this thing begin new periods at 2 pi over at 2 pi. So what's the period of the whole problem? Remember doing that? Now, there's only 2 questions that are going to be asked in that whole section. 2 questions. One is, what's the period? Okay, we got that. The other one, is it a sinusoid? And the answer is no, because the only way it can be a sinusoid is if what? These two match. Okay, so that's on the quiz. A question like that's on the quiz. What else? A question like this is on the quiz. What does that say? What in the world does that even mean? Oh, the great mystery was solved last night by who, we couldn't figure out who put the desks in this arrangement. It was the cleaning lady, yeah. She couldn't get it, she couldn't sweep.
Mrs. Ford?
Uh-huh,
Do you have Annabelle Palma with you at this time?
I do.
May I have her to the front office with her car keys, please?
Uh-oh, yes.
Thanks.
Hurry back, Annabelle. Okay, what does this problem say? This is on tomorrow's quiz. What does it say? Maggie.
Well, it has to be graphed in quadrant.
Okay, what does it say? What am I looking for? Find the angle whose cosine is negative root 3 over 2. Shh. We've talked about this a lot. When do you press this button on your calculator?
When you're trying to find an angle.
When you're trying to find an angle. So what am I trying to find here? An angle. Now I'm going to do this without a calculator. I'm going to find the angle whose cosine is negative root 3 over 2. Now in order to do that, I have to draw a picture. Where will I draw my picture? Well, remember, this function, oh gosh, there's lots of rules to know. This function is only defined on the top half of the circle. How do I know that? I memorized it. If that number's negative, then I must be looking in quadrant 2. Would you agree with that? The cosine is negative root 3 over 2. I recognize that triangle. If I'm doing this without a calculator, I have to be able to recognize the triangle. How big's this angle right here? This one right here, that guy right there. He's 30. The answer is not 30. The answer is 150.